In this presentation, I'm going to tell you about NetBox plugin I've been developing. Its name is Validity. When you have a large network with thousands of devices and dozens of engineers who make configuration changes, the chance of making a mistake increases dramatically, and it becomes really difficult to keep your configurations error-free. So Validity is a plugin that helps you to ensure your devices are provisioned in a proper way. You define compliance tests as Python expressions. Validity executes these tests and finally tells you which of your devices are provisioned properly and which are not. It's like the auto test from the software development world. First of all, to use Validity, you have to store your device configurations in a Git repository. Then you need to define a config serializer to translate your configuration from plain text into JSON. Then you create a device selector to define a subset of devices which will be a subject for the tests. Then you create one or more compliance tests as Python expressions with possibly some JQ expressions. If you're not aware of JQ, it stands for JSON query, and it's a tool to effectively extract information from complex JSON structures. I'll show you an example later. And the final step is to execute the tests against the devices and pick up the results. A couple more details about config serialization. Validity uses TTP, which stands for Template Text Parser. TTP allows you to define simple and readable templates to translate your configuration into JSON. Here you can see the example. We have this initial data, then we apply this template, and this JSON will be the result. I think very simple, very readable. Here you can see some of the test examples. The first one checks that the device hostname is in your config matches the following naming convention: device name from NetBox, a dot, and device site short name. It's also mentioned as site slug. The second test checks that the device has two NTP servers provisioned equal to 1234 and 5678. Let's go next and check out the more complex example. This example intends that our devices are broken up into pairs. Inside Validity, I call this approach dynamic pairs. You may leverage this pattern when you want to compare two devices between each other. In this example, we are going to compare the configuration of all port-channel interfaces between a device and its dynamic pair. To do this, we use this JQ expression, this one. The expression tells us to get the interface's top-level key, then we select only the items whose name starts with port channel. And finally, we make a dictionary where the key is the interface name and the value is the interface config. Finally, we just compile these new dictionaries for a device and for its dynamic pair. And we went to a live demo. Here is my local NetBox. We don't waste so much time, and I've already pre-provisioned all the necessary entities. Now I go to devices. Here we have 4 devices created. Let it be device 11 and serialized config. Here you can see the serialized configuration for this device. And here is the original config on the GitHub. So just a plain text of configuration. As you may see, it's only a part of an original config, only the part that is required for our tests. Now I go to tests, Validity tests, And here you can see our 3 tests that I've mentioned before. Hostname test, here it is. Then NTP test. And the last one, our port channel test. So now let's execute these tests. I go to customization scripts, then run compliance tests, and run script. So it takes a bit of time to finish. And now it's finished. Let's go to compliance report. Here is the overall statistics, and here is the statistics for per device. As you can see, device 11 has compliance passed, and all the other devices have compliance failed. Let's review the errors. First one, hostname test. As you can see, our hostname from the configuration is device 12, according to our step-by-step evaluation. So our hostname in the config is device 12, but by our naming convention, it has to be device 12.site1, and they are not equal, and the test is failed. Let's go next. NTP test for the same device. The same here. NTP servers from the config are 1, 2, 3, 4, and 5, 6, 7, 7, and they have to be 1, 2, 3, 4, and 5, 6, 7, 8. Here you can see the difference. It's deep diff. Let's go next. And the most complex test here, it's our port channel test. As you may remember, we are comparing the all port channel configuration from device configuration and from device dynamic pair configuration. We can scroll down and see that port channel 111 in our dynamic pair has no VLAN 300, and here is the configuration of VLANs for dynamic pair, and here is this configuration for our device, and they are not equal, so the test is failed. So that was basically all that I was going to show you. For further reading, please visit Validity GitHub page. Here you can find more information about how to install and use the plugin. And let me open the final slide. Yes, here it is. Here is my contact information. Feel free to message me if you have any questions. And finally, I want to say that I'm open to work now. So in case of any open positions related to Python backend or infrastructure automation, feel free to reach me out. That's all.
Awesome.
Thank you.
Thank you so much, Anton. That was a pretty impressive way of running checks like that. I've seen some other implementations out there that feel pretty heavy, but this didn't feel all that heavy. How long did it take you to develop this?
Yes, it was one of the main goals.
Okay. We do have maybe time for a quick question if anyone wants to toss something in chat or speak up.
I have a question actually, Anton. Have you considered using Yang models to get the configuration straight from the devices and translate those to JSON and stuff like that?
So actually, no, I haven't. I think pulling the configuration directly from devices, it's a kind of a task that is already resolved by many of the ways, and it's just maybe it's just too complex for this plugin, I think.
No, it
I
was
still think
it was more into like parsing and configuration against the Yang model. So basically, the Yang model, instead of using TPP, would tell you which fields are what, and so on and so forth.
so. Actually, I haven't thought about it before, but I think it's a good idea.
Great. Anyways, thanks for answering.
Cool. Yeah, if anybody has any other questions for Anton, we'll go ahead and hold on to those until the end.